Hey everyone, today I'm back in the school, and in our math today we are working on some more fractions. That's what I'm talking about. Let's do it. Hey, so before we get going, just a reminder, if you have yet to watch and do the work on fractions from last week, to please do that first. Otherwise this may be a bit confusing, and so I strongly recommend you go do that video first. Okay, let's get going. Remember, in fractions we have something called the numerator and the denominator. The numerator is always on top and the denominator is always on the bottom. So looking back to last week's lesson, this is a little bit from last week. Remember, a fraction shows equal parts of a whole. So let's say we're looking at a pizza. We have one whole pizza. If we are talking about half of a pizza, or 1/2, the numerator represents the number of parts counted or separated. So 1/2, or 1 out of 2, so we have 1 part here, 2 parts here, cut in half, equal pieces, equal parts. 1 out of 2 of the parts have been shaded or eaten. And the denominator represents the bottom number, and that represents equal pieces of the whole. There's two equal pieces, 1, 2, and one of them has been eaten, so the numerator identifies the top part, the one part that's missing, and the denominator represents the 2 equal parts in total. So today what we're going to be doing is comparing fractions. So let's look at these two fractions. We're going to compare them, and we're going to decide which one is the greater or the bigger, the larger fraction. So this fraction here, it says we're looking at 2/3 of this circle. So let's fill it in, 2/3. 1, 2. So 2 for our numerator. 2 parts have been selected, and in total there's 3 pieces. Perfect. And this one is 1. So which one is larger? Which one is greater? You're right. It's the 2/3. There's 2/3 of this circle there, and there's only 1/3 of this circle there. This red part is bigger than this red part. So remember when we were comparing numbers earlier this year, Pac-Man? We used the Pac-Man symbol to show which number was larger, because Pac-Man always ate the larger number. It'll be the same with this. So Pac-Man eats the larger number. You can see his mouth. Pac-Man's mouth is now pointing towards the 2/3 to indicate it's larger. And if you want, you can make some teeth to show his teeth. See, I got my teeth, pointy teeth, eating the 2/3. That's his mouth. Or if it helps you, you can just color and draw in Pac-Man and show Pac-Man eating the bigger number. So 2/3 is larger or greater than 1/3. In this next example, we have two fractions. We have 3/5. So 3/5 or 1/5. Which one's larger? Which one is Pac-Man going to eat? Remember, Pac-Man always eats the larger number or the larger fraction. So how would we represent that? So yeah, we can write our arrows like this, make an arrow pointing that way because that's eating the bigger number. Or we can put our Pac-Man in. You can draw a Pac-Man and he's eating the bigger number. Let's say you have a question like this where they give you the fraction, the symbol for it, and you have to write out what the fraction would be and then determine which one is larger. How would you do that? I'll give you a second here to think. Which one is larger? And first of all, what does each one represent? What is the fraction for each one? Take a second to count how many equal pieces there are. What's the numerator? What's the shaded portion? And how many pieces are there altogether? Or were there at one point? You might want to pause your video for a second before I reveal the answer. So just pause it now and just think about that for a second, and I'll show you in a second. You just press play when you decide which one is larger and what the fractions are. You're right. They're both 3/4 or 3/4. They look different, but both of them are the exact same. They both have 3/4 of it remaining are shaded. So we will use the equal, so we wouldn't use any arrow or mouth or Pac-Man symbol. We use the equal symbol because they're equal. They're both the same. This side is the same as this side. What we're going to learn and look at now is what happens if we're comparing fractions and the denominator is the same. How do you, without even having to draw the model or draw a picture. So let's say we have 2/5 and we're comparing it with 4/5. So our denominator is the same. We have the same denominator of 5 for both fractions. So we know whatever it is, whether it's a pizza, whether it's a chocolate bar, they're both going to be the same, and they're both going to be split up the same way. So let's just split it up into 5 here. Just looking at it, not even looking at the picture, we know it's split up into the same number of pieces. So the number of selected pieces, which is our numerator, we then know that if it's the top number, the numerator is bigger, we know that fraction's bigger. So automatically we should know 4/5 is larger than 2/5. So then we can double check with our picture. So if 4 out of 5 are colored, 2, 3, 4, or 2 out of 5, they're both the same denominator. They both have 5 pieces broken up equally. So the 2 selected pieces is going to be smaller than the 4 selected pieces. And if we look at it with our fraction blocks, we've got 2/5, 1/5, 2/5, or what's bigger, that our 2/5 are right here. Let me just draw around them so we can see how long they are. That's 2/5, or 4/5. Which block's bigger? I'll even draw around here so you can see. Obviously the 4/5 is bigger. The denominator is the same, 5, and the numerator, because the denominator is the same, we just have to see which numerator is bigger. 4/5 is larger, and so that's why it's bigger. Let's do another example here. 3/4 or 1/4, which one's bigger? Well, we know the denominators are the same, so we don't really even need to draw a model or a picture. We just know that since the denominators are the same, the one with the bigger numerator, which is 3/4, is going to be the bigger number. And then we can draw our Pac-Man symbol if you want. Okay, we got 2/7, or 7, or no, let's do 6/7. Denominators are the same, 7 and 7. 2 and the 6. Well, the 6 is larger, so we're going to eat it that way. I'll draw my Pac-Man symbol. Now, here we go on something different though. What if, again, let's not get confused, we have 1/4 or 3/8. Well, we don't want to just, our denominators are different, right? So we don't automatically look at the numerator and just pick the bigger numerator as the bigger number. We would draw a picture in this scenario. So we have 8, and we have 4. And 1/4, or 1, 2, 3/8. Well, this one is in fact bigger, but that's not always the case, that the numerator, the bigger numerator, is the bigger number, or the bigger fraction. Let's look at an example. And this is why we never want to jump to just looking at the numerator and saying, oh, this numerator is bigger, meaning this should be bigger and we should eat the 4/10. No, let's pretend we have one chocolate bar, and we're going to break it up in half, or 1/2. So there's the 1/2. Or we could split it up into 4/10. So which one's bigger? The half, 1/2, or the 4/10? 1, 2, 3, 4/10. Yeah, the half. Even though the numerator is smaller, a 1 versus a 4, 1/2, half of a chocolate bar. Let's say I'm having this chocolate bar and someone else, Miss Hinter, is having the other half. Half of it is larger if I break it up into 2 pieces. There's mine, there's Miss Hinter's, is bigger than splitting it up into 10 pieces and having 4 of the 10 pieces. So half is larger than 4/10. The next couple minutes, I'm just going to show you something, but this is for the grade 4s primarily. If you're in grade 3, you can watch and try and learn this as well, but don't feel the need to. You can skip ahead to the end where we assign some work for the week, but you can check this out as well if you like. So let's say we're comparing fractions and they have the same numerator. Remember, numerator is the top number. They have the same numerator, they're both 1. Which one is going to be bigger for comparing them, these two fractions? A trick is, if they have the same numerator, a 1 and a 1, the one with the smaller denominator is going to be the bigger fraction. So this one would be the larger one because it has the same numerator, 1, that's a 1, but the denominator is smaller, a smaller number. That means they each are only going to be broken up into one piece, each fraction, but because this is a smaller number, the pieces, there's less pieces, meaning there's bigger pieces to the fraction. So if we have a circle, we have a pizza, right? We've got a pizza pie, and we each get one piece. If I have to only share that pizza with one other person, let's say me and Miss Hinter are splitting a pizza, we each get one piece, or we get half a pizza each. We get one large piece each. But let's say it's me, Miss Hinter, and 6 other students in our class. So there's 8 people total. So we have a denominator of 8 total equal pieces. We each get one piece. Well, we're going to get each one small piece versus if it's just me and her, we get one large piece. So remember, if they're both the same on top, the numerator is the same, the denominator, the smaller amount, or the least amount of pieces we're cutting up to is the bigger fraction. Let's do another example. So we have 2/3 or 2/3, and we have 2/4 or 2/4. Which one is larger? Well, right away I can tell 2 and 2 are the numerators, right? So that we're each going to have the same amount of pieces. However, our denominators are different. 4 pieces or 3 pieces we're splitting it up to. Well, we know right away, since the numerators are the same, the one with the smaller denominator will be the larger one. Since this one's only 3, we only have 3 pieces, each of the 2 pieces are going to be larger. So, let's take a look. 2 pieces or 2 pieces of 2/4. So, 2/3 is larger than 2/4. So we'll make our arrow like this. So we have 3/5 or 3/5, or we have 3/12. Well, our numerators are the same, so the denominator that's smaller is going to be the larger one. Because there's 12 small pieces, I only get 3 of the 12 small pieces, or I get 3 of the 5 large pieces. So 3 large pieces is bigger than 3 small pieces. So in these questions, you're going to well, first of all, it's for both the grade 3 and 4 students. You're going to just on your paper, look at your question and write down question A. You're going to write down the fraction for both of these circles for this particular question, question A. And then you're going to write down which one is greater with using your arrow symbol. So for question A, you'll have your A like this. Let's say there's a circle, there's a denominator of 4 on that one and a denominator of 4 on that one. It's not the correct answer or correct thing, but let's just say that 2 of the 4 were shaded in on the right circle, 1 of the 4, which is not how it actually is. Then I'd say, okay, I know this one's bigger, and that's how I would indicate it on my paper. I don't need to do the Pac-Man logo though. Then I'd go to question B. I'd write down 7/8 or 8/10, and indicate which way it goes, or maybe it's equal to symbol. But please pause the video here if you need to work on your questions now. Same, keep working on your paper with these questions. These ones, they have the same denominator, so what's our trick if they have the same denominator? What do we do? For these ones, please write out, for G, H, and I with the pictures, write out the 2 fractions and then show me the arrow, please. And for these ones, if you can draw out the 2 fractions and then make an arrow for which one is the bigger, or they use the symbol for the greater symbol for which one's the greater fraction. These final 4 questions are just for the grade 4, so you're writing down, so it's like question R, 3/5, 3/6, and if you need to draw a picture you can, but you're deciding which one is greater. And remember our trick, these are all questions with the same numerators, so what's our trick? If our numerators are the same, how do we use, looking at our denominators, how does that help us determine to figure it out? Best of luck, guys. If you have any questions, just rewatch the video or send me an email. Okay, bye. Have a great day.